Welcome to this video of aspireforgmat.com. Before attempting this question, please take the practice test at www.aspireforgmat.com and then verify your answers against this video, which will be available after you answer the question at our site. The link for the free Aspire for GMAT course is also available in the description box below. Just register on the site and enroll for the course. There are many such tests available. If you have any doubts or queries that you would like us to clarify, post in the GMAT forum and we will answer your questions. Our instructors can also solve these problems in a video which will be available at our site for your benefit. Okay, the next question we are going to deal with is this one. If R and S are integers, is R by S an integer? Now the two conditions that are given are that every factor of S is also a factor of R and every prime factor of S is also a prime factor of R. Now this is one of those questions which is based on examples. You would have to work out this question either based on examples or based on your understanding of what a prime factor is and how you could arrange them between S and R. It would be easier in case you would take out examples, use examples for this problem. So we're going to find out how to use examples for this problem. So this is a question. If R and S are integers, is R by S an integer? So the information provided to us in the question is that R and S are integers. That is, there are some sort of whole numbers, they're not decimals. And what is asked is R by S an integer? That is it also a whole number? It's not a decimal, it should not be a fraction, it should not be anything else apart from an integer value. So that is what the question is. If we can give satisfactorily a yes or a no, we know that that particular option with the statement that can give us a yes or no to this question is sufficient. Even if it gives a negative answer, if R by S is not an integer, that is enough. That answer is sufficient, that option is sufficient, because it gives us an answer to whether R by S is an integer. So that is what we are supposed to evaluate. Now we will take these statements one by one and we will evaluate them. For example, let's take the first statement. Every factor of R, S is also a factor of R. So what is mentioned here is every factor of R is a every factor of S is also a factor of R. Now the best way to do such problems would be to take examples, because at the point while you're doing exam or whenever you get such questions, it is difficult to sort out all the scenarios in your head or do it in any other way. For example, when you get such a question, you cannot do it in any other way apart from taking examples. You might try to take out the principle or work with principles, but while you're doing the exam, it's not, when you're doing the exam, when you're writing the exam, it's not a great time to pick out such principles and form such rules. So when you're doing the exam, unless you have such pre-formed rules, it's better to go with examples. Now in this case, examples would actually be a very shortcut or a straight method, because these sentences, they just seem simple, but when you take examples, you find out that there are different ways of putting these sentences, of using these sentences, and those ways would tell you whether R by S is an integer or not. For example, instead of me just talking all so much, let's try to figure this out. Every factor of S is also a factor of R. Now that means every factor of S, it could be a prime factor, it could be a non-prime factor. Every factor of S must be a factor of R. Now let's consider that S has three factors, 2, 3, 5. Then R must also have these factors 2, 3, 5. That is what the first statement says. So let's consider that R has only those factors of S. It has nothing else. It's made up of nothing else. R has just those factors of S. Such a case is a very simple case. R by S would be 1, definitely. However, now there are two scenarios. One is that every factor of S is a factor of R. That is what is given to us. However, is every factor of R a factor of S? Every factor of, now let's confirm that by taking an example. Same example, S is equal to 235. 2 into 3 into 5. R is also equal to 2 into 3, 5. 2 into 3 into 5. Now if I take another factor 7 into r, if I multiply r, that is 2 and 3 and 5, by another factor 7, and I take that factor into r, would that factor necessarily have to be a factor of s? No, that's not mentioned anywhere in the statement. Statement just says every factor of s is also a factor of r. It never says anything about every factor of r being a factor of s. However, since it says every factor of s is a factor of r, all factors of s, for example 2, 3, 5, let it be any non-prime factors also, for example 4, 8, 12, all those have to be a factor of r. However, every factor of r need not be a factor of s. So r can have an extra factor, say in this case 7. But when you divide r by s, r would always be greater because it would have some extra factors. You multiply those factors together, it would give you an integer. So r by s would always be an integer. The factors, the common factors between r and s would cancel out, and the extra factors remaining in r would multiply to give you an integer. So r by s would always be an integer, and therefore this answer is sufficient because it tells you that r by s is an integer. Now it's fine, this answer is sufficient, so we know that a is sufficient. We don't know anything about b, so we cannot say that 2 is not sufficient or anything. However, b says over here, if you see these options that we actually have, you can just cut them, eliminate them right now. B says that only 2 is sufficient, 1 is not sufficient. Definitely we know 1 is sufficient, so that's wrong. C says that 1 and 2 together are sufficient. Now that is wrong because we know 1 is sufficient, 2 is not required for 1 to be sufficient. D says 1 and 2 might be sufficient individually. Now we don't know whether 2 is sufficient or not, so we cannot say it is. And E says that both of them are not sufficient individually or together. Now we know 1 is sufficient individually, so E is also wrong. So the answer has to be between 1 and D. Now let's evaluate the second option. Every prime factor of s is also a prime factor of r. So what does this tell us? Every prime factor of s is also a prime factor of r. So this can have multiple scenarios. If you see, actually this particular option is a sub option or a subset of the first option. Every prime factor of s is a prime factor of r. What about non-prime factors? They need not be factors of r. They could be just factors of s. They could be just factors of r. Okay. So first you have the same scenarios that we considered here. If you see here, we've taken the same scenarios. S is equal to 2 into 3 into 5. R is equal to 2 into 3 into 5. And r by s will be an integer. So that's all right. Again, s could have certain factors and r could have some extra factors. They need not be factors of s. So r by s would be an integer. But what about scenarios in which s has certain non-prime factors? For example, s could have 14 and r could have 6, or say let's say r has 8. 6 wouldn't be valid. So let's say instead of 6, let's say instead of 6, r is 8. Okay. So let's say r is 8. So r has a factor 8, s has a factor 14. Is 14 a prime factor? No. It consists of prime factors, but it's not a prime factor in itself. R is not a prime factor. 8 is not a prime factor. It could even have something like, it need not even have 8. If you think that, okay, certain people might say 14 is equal to 2 into 7, 2 and 7. And 8 has 2 into 4. So 2 and 2 cancel out, 7 and 4. 7 is a prime factor. 7 needs to be a since every factor of s is also, every prime factor of s is also a prime factor of r, 7 would need to be a factor of r. Okay, that is a valid point. So let's even work that out, and let's say that this has a factor called 9. Let r have 9. Now what happens? S is consisting of S has 2 into 3 into 5 into 14. Now 14 has 2 and 7 of course, but they need not be a prime factor of R, because together 14 is not a prime factor. Together 14 is just a number. It's never mentioned anywhere that these numbers or these factors would have to be a single digit factor. It's not mentioned anywhere. I could have S is equal to 14. I could have R is equal to 9. 9 has 3 into 3, two factors, two prime factors. That is the same prime factor repeated again and again, 3 into 3. So 9 is also not a prime factor. However, if you find out in such situations where R has a factor which is smaller than S, the factor of S, and so that R by S is not an integer, such a situation can also arise. If you see this particular example, you will get 9 by 14. It's not a prime factor, it's a fraction. So in such cases it would be insufficient. Option B would be insufficient. Now we know the second option is insufficient. It can give us a situation where R by S is an integer. It can give us a situation where R by S is not an integer. So it's insufficient. So D can't be the answer, because D says that second option is also sufficient individually. So therefore A has to be the right answer, and therefore our answer is